lesson we're going to be looking at exponents, and first of all what an exponent is and how we can take an exponent and solve it. And then we're also going to be looking just briefly at square roots and what a square root is and how we can solve a square root as well. So before we start any of that, we just need to get some vocab out of the way because there is a lot of vocab with exponents. So if this was my number right here, this is my power, we have a couple words that go with it. This 3 is our base. That's the number that's used as a factor, meaning the 3 is what we're going to be multiplying each time. And then this 4 is the exponent. That's how many times we're going to be writing the 3 over and over again. And then we call the whole thing the power. So 3 to the 4th power, that's how we would read this, means take 3 and multiply it by itself 4 times, or 3 times 3 times 3 times 3, which would give us 81. So the base is the number that we're going to be multiplying. The exponent is how many times we're going to be multiplying that base. And then just a little tidbit that might come in handy later on is that anything to the 0 power is 1. So 3 to the 0 power is 1. We could spend a whole lesson just looking at why that works, but for now it's just so you know, anything to the 0 power is 1. So we're going to try some problems, some exponents, some powers, and we're going to see if we can solve them. And so the easiest way to solve these is to write them out in expanded form, meaning write the base the number of times that the exponent tells us. So this one says 3 squared, or 3 to the 2nd power, so I would write out 3 times 3, because the base is 3. The 2 tells us how many times we're writing out that number, and we're always multiplying when we're working with exponents. So then we can just multiply just like we would for order of operations, and we have 3 times 3, which is 9, and that would be our answer. Here's another one. We have 2 to the 5th power, so that means the base is 2. That's the number that I'm going to be multiplying, and I'm going to multiply it by itself 5 times. So I'm going to write out 5 2's. So now I can just multiply them all together. I have 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So 2 to the 5th power is 32. If you can't do that whole thing in your head, you can write it out, do one step at a time, just like we would for order of operations. So I could do it like this. 2 times 2 is 4, and then rewrite the rest of the problem. So same thing as we're doing with order of operations, and then we can just keep moving to the right. Then I have 4 times 2 is 8, rewrite the rest of the problem. 8 times 2 is 16, rewrite the rest of the problem, and 16 times 2 is 32. So we still get the same answer, it's just written out. For 2 you might not have to do that, but when we get to some bigger numbers it might be nicer so that you can keep track of what you've all multiplied so far. Here's one more we'll try, 4 to the 3rd power. So remember the 4 is the base, the 3 is the exponent. The 4 tells us what number we're going to be multiplying, that's what the base tells us. And the exponent, that 3, tells us how many times we're going to be writing that number out. So here I have 4 times 4 is 16. I can rewrite the rest of the problem. And 16 times 4 is 64. And that would be my answer. Now, sometimes we might not just have just one exponent. Sometimes we might have some exponents put together. And we can solve these ones the same way. 2 to the 2nd power times 2 to the 3rd power. Well, if I were to write this out in expanded form, 2 to the 2nd power would look like 2 times 2. I'm going to pull down that times sign, and I have 2 to the 3rd power, or 2 times 2 times 2. So another way to write 2 to the 2nd power times 2 to the 3rd power is 2. That's the number that I'm multiplying here. And how many times am I multiplying it? 1, 2, 3, 4, 5. 2 to the 5th power. So whenever you're multiplying exponents and the bases are the same, we can rewrite it by just adding those exponents. And now I can simply solve it just like before. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So this will give us 32. So if we try this next one, before I even write it out in expanded form, I could rewrite it so that it's all one exponent because the bases are the same. So I would have 3 to the 1 plus 3, or 4th power. And that, we can write it out in expanded form. So 3 to the first is, write a 3 one time. Pull down that times sign, and then 3 to the third power, or 3 times 3 times 3. And then we can simply multiply them out. 3 times 3 is 9. You can write out the rest of the problem. Times 3 times 3. 9 times 3 is 27. And 27 times 3 is, 7 times 3 would be 21. And this would be an 8, so 81. Instead of multiplying exponents, we also have the option of dividing exponents. So we can write it all in expanded form and see what that looks like. So 5 to the third power means 5 times 5 times 5. Divided by, I'm going to keep that fraction bar there, 5 to the first, or 5. Now we have two options here. We could either multiply the top, multiply the bottom, and then divide, or we can also look at this like a fraction. Here I have 5 over 5, and 5 over 5 is 1. So these kind of cancel each other out, because this is basically just saying 1 times 5 times 5. So I can get rid of those two. And now I can multiply what I have left, which is 5 times 5, or 25. So another way to write problems with exponents and division is to write the base, and then I can subtract the exponents. 3 minus 1 is 2. And that's what I ended up with, 5 squared, or 5 times 5, which is 25. Before we write this one out in expanded form, let's see if we can write it as one exponent. So I'm going to write the base, which is 2. And then I have 4 on the top and 3 on the bottom for exponents. I can subtract those and get 2 to the first. So our answer should be 2. Let's check it by writing it in expanded form. 2 times 2 times 2 times 2 would be on the top, all divided by 2 times 2 times 2 on the bottom. And now I can cancel some of these out. 2 over 2 is 1, so those cancel each other out. 2 over 2 is 1, so those two cancel each other out. 2 over 2 is 1, so those two cancel each other out, and I'm left with 2. So our answer is 2, and that's what we said it was going to be. So if you are dividing exponents and the bases are the same, simply subtract the exponents so you don't have to write it all out. There's not so many steps. And the last part we're going to look at with exponents is square roots. And square roots and exponents go together because they're opposites of each other. A square root means what number times itself will give us 9. So I'm just going to write it like this. What number times itself will give us 9? And when we think of square roots, sometimes we can think of a box or a square. And when we're finding area of a square, the sides have to be the same length. And the area would be what it is when we multiply. And that's what we're doing with square roots. We're trying to find the length of each of those sides. So what number times itself will give us 9? Well, 3 times itself, or 3, will give us 9. So the square root of 9 is 3. I can do the same thing with the square root of 4. What number times itself will give us 4? Well, I'm thinking about it like a square and finding the area. What number times itself will give us 4? What's the length of each side? 2 times 2 will give us 4. So the square root of 4 is 2. I can do the same thing here for 25. What number times itself will give us 25? And so, going back to our square over here, what's going to be the length of each side? If we multiply them and get 25, 5 times 5 is 25. So the square root of 25 is 5. So this has been just kind of an introduction to exponents, looking at how to multiply them, how to find exponents, how to divide them, and also how to find a square root.